Oh, hey there. Welcome to Studio Z. So today we're going to take a look at vacuum tables. So you might be asking yourself, what is a vacuum table? Well, a vacuum table is just another means of clamping down or using clamping force to hold down your workpiece to the table. And the thing about vacuum table is that there are no clamps, there's no double stick tape, there's no crazy glue or blue tape, that kind of method that you were using. This eliminates all of that and you're just using suction. I say that in quotes because we'll get into that a little bit later on. You'll be using suction to hold your piece down to the table, and that's it. There's no mechanical means of holding it to the table. All right, so now that we know what a vacuum table is, let me bring you in closer and I'll show you the individual parts that make up the vacuum table. All right, so this is the vacuum table itself. This particular one happens to be 2 feet wide by 4 feet long, and it happens to be made by Airweights, and I'm not sponsored by them, so this is not a tool review. I'm just merely showing the product. So that is the table itself, and it also has a hose that connects from it to the pump, and this is the vacuum pump itself. Okay, and the most important part of the vacuum pump is the gauge, and I'll zoom in on it here. And all vacuum gauges are read from inches of mercury, and that is very important. I'll explain that in a little bit, and we'll get into detail about the importance of knowing how to read that. But for right now, what you need to know is that these are the 3 essential components of a vacuum table: the pump, the lines that connect it to the table, and the table itself. Okay, so for the table itself, I'll briefly go into how it works. And it's made out of a plastic with a metal bottom on the underneath that completely seals it. And the top of the table has a grid work of, let's say, grooves carved into it that you can attach supplied strips of membrane. That's what this is right here, so that you can section off certain parts of the table to make it smaller or larger, however it suits your needs. And there are various openings in the table to allow this vacuum to come through, and you can either keep them open or you can close them off in other areas with these stoppers to control where you have the vacuum on the table. As well, there's also a fastening point so that you can fasten the table to your hybrid table so that it won't move. And there's also dowel pin points in it so that if you want to, you can cover this. I'll go in this later, but you can cover this with a sacrificial board of MDF, and you can use the dowel pins to locate that so that it doesn't move around. All right, so that's in a nutshell how the table is laid out. Now I'll go into a little more depth as to the types of surfaces you can use on it and how to use it. All right, so now that we've seen the parts that make up a vacuum table, I want to go into reading the gauge. As I mentioned, how important it is to know how to read that gauge. And it's marked in inches of mercury. So what I need to explain, and this can get a little complicated, but it is really important to understand, especially if you make small parts, like small diameter parts. So the way a vacuum table actually works is when you turn on the pump and you create suction underneath the board that you're working on and the vacuum table itself, you're creating a void. And that void or vacuum wants to be quickly filled by the atmosphere above us. And that atmosphere at sea level, is pressing down on everything around us at about 14.7 pounds per square inch, again, at sea level. So that void that you're creating is in the force that you're feeling of the suction going down is actually the atmosphere trying to replace it and pushing down on it. Now, it's limited. So meaning when you turn on the vacuum pump, whatever the atmospheric pressure is where you are, say you're at sea level, you're only going to be able to get a maximum of 14.7 pounds per square inch if you were even able to achieve a perfect vacuum, which again, I'll get into that even later on. But if you live at a higher elevation, say like in Colorado, and you're, I don't know, let's say 5,000 feet above sea level, well, that number is going to be significantly lower because there is that much less atmosphere above you weighing down on the piece that you're working on. And you would need to know how to convert atmospheric pressure in inches of mercury to PSI, which is really quite simple. 1 inch of mercury is equal to about 0.491 PSI. I generally like to look at it as 50%. So if you have 29.97 inches of mercury, it's very close to 15 PSI or 14.7. That's the easiest way to look at it. And I happen to live where I happen to live. I'm about 450 feet above sea level, so I'm just slightly under that, ever so slightly. So that's just the easiest way to know how to convert inches of mercury to PSI. And the reason, again, for that being so important is I've got a board here that is 6 inches by 11 inches, and it has 66 square inches of surface area. And using that rule, on my setup, with what I'm using, I can get about 13.5 PSI of pressure based on my setup through leakage, so on and so forth. Again, I'll get into all of that later on. But for right now, if you were to apply the 66 square inches times the 13.5 PSI that I can attain, I'm putting roughly about 900 pounds of force on this little board. It's really high. That's a lot of force. So this is not going to move anywhere when I'm trying to hold it down on the table. But there's limitations. So if you are making small parts, and this is where it comes into being important, say you're only doing a 2 inch by 2 inch piece, which is 4 square inches. Well, now, you've only got, what is that, like a little over 50 pounds holding that little piece down. And that can be problematic if you're using a high feed rate, an upcut bit, which has a lifting force on it. It can move the piece off and dislodge it and break the suction, so to speak. So that's the reason why it's so important to learn how to read the gauge. Mainly if you make small parts. If you deal with mostly large boards, it's really not going to apply because you're going to have so much force or suction holding that board down that it's not going to matter. All right, so now that we know that, let me go into the different types of surfaces that you can use to work on. And those are pretty simple. I've got set up here a board of MDF and I've covered it with tape. So I don't know if you know, but MDF is really permeable and you can draw a vacuum straight through it. It doesn't hold, it's not airtight, watertight. So if you put any kind of suction on it, it will draw straight through it. And that wouldn't work very well if you're trying to hold something down because you're going to have a massive leak when you're trying to hold something down to it. So what I've gone ahead here is I've taped off the entire surface area of the MDF board, and even on the bottom where it will mate up with the gasket underneath it so that I get a really nice tight seal. And I've left the center of it open to the same size as this particular board that I'm using as a demonstration, so that is where the vacuum will be drawn through. It will be drawn through this area right here. And this actually produces quite a bit of vacuum, as I'll show you right now. I'll turn on the pump, and I'm getting 25 inches of vacuum on this particular setup because of leakage through this particular setup. So this board, has roughly 800 something pounds of force now holding it down, because I'm only getting about 12.5 PSI, pounds per square inch on this particular board. And there is no way that you can move that. It's not going anywhere. So you can see just how strong the grip or the suction is on a vacuum table. Now, this suction force is extremely strong laterally, going, this way. You can't move it. But it's not very strong on an upward motion. If you pull hard enough, you can actually break it, and as you can see, it'll come off. But again, it's primarily for lateral strength. When you put it on like that, there's no way to move that. All right, so that is just one example of how you can use the table. And the reason you would use this setup is, let me shut the pump off actually. The reason you would use this kind of setup is if you wanted to cut through the piece that you're working on. And the reason is this particular MDF board underneath is now sacrificial. And you would be able to cut through this. And yes, you would get a minor vacuum leak in it wherever you cut through, but the loss would be pretty minimal, and the board would still be in place and you wouldn't lose it. Conversely, if you were to not use this and just work directly on the table, that is absolutely possible. However, if you do that, you then have to, let's say we're still using this board and we were putting it on the table, straight on the table, you now would not be able to cut through it. You would have underneath this a system of the gasket, on an outline of this rectangle on the table over one of the ports. And if you were to cut through this at any point, you would have a massive vacuum leak at that point. The board would come loose and it would kick into the bit and it would be disastrous. So if you're working directly on the table, that is only for surface work. You would only be able to do that. You would not be able to cut through it again. Otherwise you would break the vacuum and it would be disastrous. So working on the table is strictly for surface work. If you want to cut through, you can use either the MDF as I showed you, or they also make other types that you can buy. This one also happens to be 1/4" MDF with a rubber type membrane that is adhered to the surface. And it's basically the same thing as what I just showed you with the blue tape. However, it has a little bit less leakage due to the better surface. This rubber is much more sealed, so you'll get a higher suction rate from this, and it's really good. It also can be, you can use the locating dowel pins on this so that you can set it in place and have a decent reference point to start from. So again, just another method of how to do it. The third way, or the third type of surface that you can work with, is even larger, and this also comes with it. And this is a very large sheet of 1/4" MDF. And again, this has no sealing on it whatsoever, so it is wide open. And this would be for large parts. And in order to use this, whatever your part might be, I don't know, let's say you had, some kind of long board, something like this that you were working on, and you needed to hold it down. The remaining area of the table, you would have to figure out some way to seal it. On this type of table, because it's a low CFM vacuum table, you would need to figure out some way to seal this other area so that the loss in vacuum wouldn't be so much and you can hold your part down firmly and not lose it. If you were to use it without that, the hold that you'll get from it is not going to be incredibly strong, and the part could move under the forces of the router. So not recommended. You would have to figure out some way to cover the surface that's exposed. All right, so now that I've shown you the types of, let's say, surfaces that you can work off of, I've gone back to the original one that I was showing you, and I'd like to talk about the advantages and the disadvantages for a vacuum table. So the advantages for a vacuum table are primarily two things. One, the speed at which you can change your workpiece. And the second one is that there's no clamps in the way. So if you're, I don't know, working on an entire surface of a part and you have no clamps to worry about, nothing to bang into, so you kind of have a lot of freedom and not have to worry about the spindle or the router bit hitting anything that could potentially be in the way. But the main thing is the speed with which you can change the part. So if you're, the real, let's say for me, the real benefit of a vacuum table is if you're making a lot of parts. So say you are, I don't know, let's say they're making little trays, right? And you're making about 500 of them of the same exact tray, and you have 500 blanks already drawn up for that. It is the fastest way to machine those parts and get them turned out. And the reason for that is, I have this particular setup made exactly for that to demonstrate it. So once you have this surface located, and let's say you use the dowel pins to pin it in its place exactly, you would then set up a 90-degree corner like this so that you have a locating point. You would set your block on there and you would reference off of this corner, and you would go ahead and machine your first tray. You know, usually a tray, something of this size, might take 20 to 30 minutes, something like that. Once it's finished, and you can cut through it and, you know, cut the profile out, because again, with this type of setup, you're not going to lose it. It will be able to hold that tray down. You can just take it out, you know, come in with another one, set it right down, turn the pump back on, and, you know, do your second one, your third, fourth, so on and so forth. Really quick, fast change between one to the other and going that way. Whereas, you know, if you go the conventional method with using, you know, double stick tape or clamps or the crazy glue on top of the blue tape, you know how long it takes just to peel that tape off, put another one on, or just, you know, the crazy glue and having to put new blue tape under it. It takes forever. Even with clamps, you know, you have some type of way that you either have to make a groove around the outside edge to grab it from the clamp from the side, if you can work off of the surface, but that's, you know, even harder to deal with. So again, all of those methods take a long time to change between parts, whereas with this, you just come in, shut the pump off, take it out, put it back on. It's real fast. So those are the two main advantages to the vacuum table. So now let's talk about the disadvantages. And the disadvantages are there's quite a few, all right? The first being cost. This particular setup, it comes in two sizes. This one happens to be 2 foot by 4 foot, and I bought the larger pump that they offer. And the reason I bought the larger pump is because I also use it for veneering. I have a veneering bag, so I wanted the larger pump for that as well. And it just happened to kill 2 birds with 1 stone for me. But this particular setup, and it doesn't come with either of these 2 extra surface boards that you can use. Those are optional. You have to pay extra for that. But this setup was between $1,800 and $1,900 for all of this. So it's you know, quite a bit to consider for something, only if you're doing it, again, I like to use it for repetitive work. That's really what I would say that it's best for. It's not really recommended for one-off type stuff. It's just not, it's not beneficial for that. Another disadvantage of it is the initial setup, meaning when you start to configure a tool path and how you want to cut it, you have to figure out how am I going to situate it, you know, like setting up this board, covering it with tape or using something else, setting up a corner for it, locating it, and making sure that it doesn't move so that you got consistency through each piece. But once you have that set up, again, that's, you know, everything going forward is much, much faster. All right, so on top of that, another problem, another disadvantage with this system is that the pump has to run continuously. That's right. So You don't want to really be using this for some type of, as I don't know if you've watched other of my videos where most of my carvings are, you know, between 3.5 to 6 hours. I do a lot of detailed carving and things like that, and they're really long machining times. So that pump has to run the entire time. It cannot shut off. If it does, you know, you will lose your part. It's going to go into the router bit and destroy it. So that is something to consider. The pump has to run the entire time that you're machining. So that is something to consider. And at the same time, you also have to factor in if you happen to blow a fuse, you know, on the line that you're using for the vacuum pump. Make sure there's nothing else on it, you know, that's powering it. Because if you trip a circuit breaker and that pump loses power, you've just lost suction, your piece is going to go flying, and you've just lost everything that you did for that particular part. Another thing also to consider is bad weather. So say you're going to have you might have a chance of a storm that day, thunder, lightning, you're going to lose power. That's what I'm getting at. And you lose power in the entire shop. So, okay, the pump and the spindle will lose power at the same time. But you're going to have to hope that the spindle stops spinning before the suction is broken on the piece. The pump, once you shut it off, takes about 1 to 2 seconds before it regains, you know, or let's say comes out of the suction. So that is something to consider, because if you lose power, and you know, sometimes the spindle takes a little while to slow down before it stops spinning, and if it's still moving, or bangs into it, again, you could ruin the piece that you're working on. And it's again something to consider, because there is no mechanical fastening with this system. When that suction is broken and you know there's a leakage or whatever, your piece is going to come loose, and the first thing it's going to go into is into the router bit, and it's going to make a mess. All right, so the next disadvantage of it is if you lose suction. So for example, say you're working on something and you didn't realize that you cut through it, you know, for whatever reason, and you break suction on it, that piece is now going to move, and you're also going to destroy that piece based on the fact that, you know, it's not being held in place anymore. The other problem with the vacuum table is that whatever piece you put on it, that surface has to be dead flat. Otherwise, you will not be able to get a vacuum to hold on it. If it has any kind of warp in the board, you know, when you put it on and you know, if it teeters ever so slightly and the surface is out of flat, it will not work on there. The thicker the board is, the harder it is to work with. If it's thin, you know, it'll flex, and you can usually get away with a little bit of a discrepancy in it. You just push down on it as it's creating the vacuum, and it will hold. But on thicker boards, you can't do that. They're much more rigid, and they won't bend, they won't flex, so you're not going to get a seal on them. So it must be absolutely dead flat, otherwise you will not get a good suction on it. All right, so now that we've seen the advantages and the disadvantages of the CNC table, the question is, you know, that you might be asking yourself, well, do I need one? Is it for me? And really that's going to boil down to, as I've mentioned all of the points earlier about the disadvantages and the advantages of it. If you do repetitive work where you're making many parts of the same thing, then I would say that the vacuum table is certainly the way to go. And again, if you're, you know, let's say not working on really small parts, but you know, medium-sized to large parts, it'd be great for that. And again, if you're just making lots of them, like, you know, 100, 200, whatever it could be, this is going to be advantageous to you, because you'll be able to quickly swap out parts and speed up your process and save yourself a lot of time that way. But if you do mainly one-off stuff, you know, this is not going to be the best choice for you, just because, again, yes, you could do it with it, but if you're making a one piece, and let's just say that something happens in the middle of that process where you break the vacuum and you lose suction, you know, it's going to ruin the piece, and there's no benefit to that. The amount of time that it takes to set up the table for that one piece is the same amount of time that it takes for, you know, using double stick tape, clamps, so on and so forth. So this won't benefit you there. It's just not, it's not worth it. And it's mainly for, like I've mentioned, just repetitive stuff where you're making the same part over and over and over. And you can make different fixtures, you know, to hold different things for specific parts and just keep them in your shop. The only thing is you have to keep them in really good shape. You know, you can't have any damage happen to them. So let's say you make a specific tray and, you know, you make that every so many months, and you make a jig for it, and you can keep that aside so that you know that whenever it comes time to make that specific tray or bowl or whatever it might be, you just pull it out of storage, put it back on the table, and you're ready to rock right at that point. So again, that's where this stuff excels, is for that kind of repetitive batch type work. Otherwise, if you're, again, just doing one-offs, really not worth it for it. It's pretty much the same amount of time to set this up as you would with a clamp or tape. So I know that it's a little bit of an eye-opener that, you know, vacuum or suction isn't quite exactly what you think it is. Especially, you know, most people think that, oh, you know, I'm not getting enough vacuum, I'll just buy a bigger pump and it'll you know, draw it down even harder. I'll get much more hold down power from it, and that's just not the case. There is an absolute limit to how much, you know, how much pressure you can have holding it down. And as I pointed out earlier, that limitation is based on the atmospheric pressure. And if you've ever seen, you know, the other industrial sized tables that are really, really large, you know, 5 foot by 10 foot, and they're running like a 60 horsepower or 40 horsepower vacuum, you know, they're absolutely massive, massive vacuums. All that is just for CFM. And basically those tables are completely open, and they don't have to use this blue tape to seal off a certain part of the area. The pump is so powerful that it can make up for that loss that's on the table being open, and you can place the part anywhere on open MDF, boom, and it'll just stick right there with plenty of pressure to keep it down. But again, not exceeding any of those maximums that I mentioned earlier. The pump just has so much, you know, CFM that it can account for loss and still not have to worry about that board moving around. So with that, again, I hope you guys learned something. And if you did, please give me the thumbs up and be sure to subscribe. It really keeps the channel going. And with that, I will see you guys on the next one.